So let's continue from where we stopped. I think yesterday we started with two-level, two-factor factorial, right? And we did the hand calculation for that. And we used the expert as an example. And I think this was what we had. We used this rating. What we call the randomization, right? And then we talked about three different charts. We looked at this one first. We looked at the main effect plots. Can you hear me?
Yes, though.
Yeah, so yesterday we looked at the main effect plot, and we also looked at the interaction plots. And for the example we did yesterday, we realized that there was no interaction. Then we looked at this was the contour plots. And later we developed the equation, which we had 6 plus 1.5 sugar plus 1. And that was the model equation used to predict our cap. Today, we are going to do a practical session of this. And so whilst I'm recording, maybe you can open on your phone and practice. And then I'll still share the video with you guys so that go over it. So we're going to go here. We're going to do Minitab demonstration of factor two-level experiment. So you can just follow me gradually as I do this, or you can also practice on your PC. So let's start our Minitab. So what I'm going to do is that I'm going to slideshow. Then I'll open my Minitab. If I want to get my Minitab, let me to come here. It's my Minitab. I hope you all have the Minitab. Okay. So when you start the Minitab, this is what you have. You're going to see something like this. Okay. Now, to start with your DOE experiment, come to start. Let's start here. You come to start. When you go to start, you click on the stats. So when you click on start, you see different statistical methods. So you see DOE here. Okay. So you come to DOE. Then at DOE, you come to factorial. When you come to factorial, you now choose create a factorial design. We are now going to create the design experiment, and then later we'll do analysis. So you click on create factorial. When you click on create factorial, you have this dialog box appearing. This one tells you the type of factorial design you want. So you see, currently default is at two-level factorial. You can change the number of factors here by changing this. You can put any number of factors you want. You can change this to 10 different levels and different factorials. If you want more factorials, you can click here. It tells you the available factorials or experiments that can be performed. Later, I'll come and explain most of this, but today we just want to stick to the two-level, two-factor factorial. As we go deeper, we keep explaining more, and you understand most of the terms. So with this, when you are here, you now click on design because you want to design your factorial. So when we come to design, we have what we call center points. To Today, we are not going to talk about center points, so just maintain it as default. Replications, like yesterday, you remember our experiment, we did not replicate it. It was just one experiment, so we maintain it as 1. The number of blocks also is also 1. Later, play around with all these units so that you see how, when to use replicates, when to use blocks, and when to work with center points. Then you click OK. When you click OK, you see that these places are now active. So you now come to factors. Then you click on the factors, where you now type your values. So our first factor was sugar, right? So we'll type here sugar. Our first factor was sugar. Then the second one was milk. Then we can come here, and if you want, you can change this. If it's string, you can. If it's a text, you can change it to text, or if it's number, you can change it to number. So you see that automatically it is giving us the coding we used yesterday: -1 or negative, and then positive. -1, positive. Because we are using what? Different levels for each factor. Then you click OK. When you click OK, then you click OK again. So automatically you see that our factorial design has been created. So you see this, yesterday we drew this table, remember. This is the first one. This is the order of experiment. 1, 2, 3, 4. This is the run order. So this is the randomization. Luckily enough, our run order is the same as the standard order. Sometimes it changes. In some cases, this one changes. But in this case, they are all the same. We did not set center point, so it should be 1. Don't worry about that. This one also blocked, should be 1. Don't worry about that. Later we'll talk about that. Now these are the inputs for the sugar and then the milk. So we had negative, negative, -1, 1 negative, positive, positive. So it's now time to run an experiment. So we had to write rating here, you remember. So the rating is the taste, right, of the coffee. The first one was 3. The second one, -1 was 6. This was also 6. And then this one was 9. Which means we have finished performing our experiment. We are done. You can now perform analysis on this factorial design. There's now data in it. So let's see how it will behave. If you want to perform the analysis, you come back to start, DOE, factorial. Now you see that all these places are now active. Initially, they were not active. It was only this great factorial, but now it is detecting that there is a factorial design on the worksheet and there's data in it and it's ready for analysis. So you now come and click on Analyze Factorial Design. Then we analyze. When you come, you see our target or our output or our response variable is rating. So you click on it, you select. So you put the rating under the response. Then you maintain this one. Later, we will explore these graphs. And you click OK. When you click OK, analysis will be run. And you can see that this is the analysis we have. Let's go first to the equation, if you remember. See the equation we have here? So the equation, the model is what? 6 plus 1.5 sugar plus 1.5 milk minus 0.00. Like this, about 17 is negligible. It means this is the interaction points. So the interaction is 0. Okay, so you see that this, you see here, similar to the similar to the equation we had, this one. That's here. You see, Similar to the equation here. All right. Let's continue. Now, when you're done, later I will explain these charts and everything so that you get to know. Like most of these variables, I'll show you what they mean, how you can use this to evaluate your model. But now we're just trying to confirm what we did yesterday with the hand calculation. Then the next thing we can see is we want to see the main effect plot. So to see the main effect plot, go back to start, go factorial, then we'll come to factorial plots. See it here. Click on factorial plots. Go to stats, DOE, factorial, factorial plot. Then you remember you choose whether you want the plot to be based on sugar or milk. You can also choose to display all terms if you want to. I just want to maintain it as it is this way. You can play around with it if you want. So you see our main effect plots. This was yesterday we did this. You can see the value here is what? 4.5. Remember that. Milk, this for sugar, 1.5. This was for milk, 1.5, and then 4.5. So you can see how sugar affects the rating and how milk also affects rate. This is the interaction plot. So you can see the interaction plot for rating. They are all parallel. This is for negative milk. This is for positive milk. The blue is for negative milk. Then you have your negative sugar and positive sugar. You can see how they interact. There is no interaction because they are all in parallel lines, like we said yesterday. Then you can also generate the response or what we call the contour plots. Explore the contour plots. You still go to start, DOE, factorial, then you go to contour plot. So you can decide to choose one you want to be on the X and then the Y. You click OK. See the contour plot here. Now this tells us how so if we want to get a very sweet sugar, we have to be in this zone, right? So this zone could be like take here is what rating? Here it's like 8. If I want to be in this rating, I can take this amount of sugar and then this amount of sugar. Not necessarily to take up to the end. But within this range, it's acceptable taste. So sometimes you can use this one to actually reduce the concentration of the sugar in the milk. You don't put too much, but you still get taste that is close to the perfect because it's going to be between 8 and 9. From here to here is 8 and 9. And you remember we said this whole line is 6. This is 6, line is 7, this is 8, and 9. You come down, this is 6, this is 5, this is 4, 3, if you remember. Exactly. So see that here. And so that's how you interpret this. Can similarly use this one also to plot what we call the phase response plot. So if you want to do that also, you go to the start, GUI, factorial, then you do surface plot. Same, you choose, then you plot. So you do the surface plot. Tells you the area of significance. Yeah, and play around with this. You have it. You can sometimes rotate it around. It's like a 3D behavior of the interactions between the. Okay. Yeah. So do you have any question on this? So this is our first practical demonstration of the factorial. Like I said, I'll share this video with you so that you can practice more and get hands-on experience. Those of you who have been able to follow laptops, I want to urge you to practice it. Right? Play around with the variables and get used to them and try to understand the interaction term, try to understand the parameters, try to understand the main effect term, because those are the interpretations you'll be asked to do as time goes on during this. Okay, so come back to our slide. So from the Minitab, this is just a concluding remark of the Minitab experiment. From the Minitab, we confirm that the model equation is still 6 plus 1.5 sugar, 1.5 mole. We confirm that the interaction term was virtually 0, and so it's not accounting this. Then we also talked about, so this was what we saw, this was how the model was, confirmed the model, comparing our results to the one we calculated, one, and then that one was this. Comparing, you remember these graphs, we drew these graphs yesterday. Minitab, it looks nicer. Same thing. This is the interaction. Then this was how it looks nice compared to what we interpret. And the explanation are all right. Any question? Yes. Now, this one is quite simple because there's no interaction between it and the calculations are easy. So in our next encounter, we are going to take an example. We'll still take two-factor, two-level, but this time we'll try to work with interaction. Then we'll see how to use hand to do the calculation. And that we'll still use Minitab also perform the experiment, and then we still compare again. So that's the rest of the examples. Just use Minitab straight up. At least I believe after doing that example, you get to appreciate or understand the concept of estimating most of the variables in design of experiment. So let's go straight up. Talk theory, then use the Minitab to perform the experiments analysis. So do you have any question for me? Your attendance is very, I don't know. Okay, so if you don't have any question, we'll, in our next class, go by class interaction with calculations. So I'll share this attendance with you. Thank you and have a nice day.
Doc, we don't have the slide.
I'll share with you. I'll share with you. I have a meeting in 10 minutes time. So when I finish, I'll try and share the slide.
Okay, Doc.
All right. Thank you.
It's